So let's start by putting those symbols to work with the easiest, maybe not the easiest, the most commonly used way of describing a sample, which is the mean. So the mean is what is most commonly what most people refer to as what most people mean when they say the average. And it's one way, although we'll come to some others a bit later, of calculating, let's say, the central value in a data set. Okay, and we can write it as x with a little bar on top is the mean of a sample, or a mu with a little bar on top is the mean of a whole population, if we know every single member of that population. And in my on this slide, I'm just going to write x, but it's equally true for the mean of a whole population. Okay, so everything goes for both. Alright, and here's the most important thing. So x, or mu, is equal to the sum of all the x's over the number of values. So we can say that's the sum of all the measurements divided by the number of measurements. So I'm just going to show you a couple of examples. So how about this data set? So got my curly brackets around the different values. So I've got 2, 3, 4, 5, 6, 7 and 8. Close the curly brackets. So there are 1, 2, 3, 4, 5, 6, 7 measurements, so that's n is 7. So the sample mean is sum of x over n, so in this case that's 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 divided by n, which is 7. So here, if we add this up, that's 35 divided by 7, which is 5. How about another example now? This other data sets that just have -5, 0, 5, 10, 15. So use that same formula, so that's the sum of the x's divided by n, so that's -5 plus 0 plus 5 plus 10 plus 15 divided by 5, because n equals 5. So that gives us 25 divided by 5. So these two samples they have the same mean, but they're two quite different data sets. So you can see that the mean on its own isn't enough to describe what the data set is like. And also, I'd like this other word of warning is that the mean is quite sensitive to extreme values. So what do I mean by that? So let's take this data set and just add another measurement on there. So we've got 2, 3, 4, 5, 6, 7, 8, and then let's imagine we take another measurement of 1,000. So now n is 8. So the mean is equal to the sum over the number of measurements. So in this case, if we add, is it 2 plus 3? All over 8, so that would give us 1035 over 8, which is 129 plus 4. So it is basically the same data set, just with one extreme value, but these means are so different between the first data set and the third one that I've been looking at. So that's another reason why the mean probably isn't always perfect for everything we'll want to do.